So today we are going to do the experiment on verification of superposition theorem. So I will start by explaining what superposition theorem is. Superposition theorem states that for a linear system, the response in any branch of a bilateral linear circuit having more than one independent source equals the algebraic sum of responses caused by each independent source. So I will explain this superposition theorem by explaining this circuit diagram which we use in our experiment. So here what we are doing in the experiment is we are having three cases. The first case is with this 30 volt DC supply. We are supplying this circuit with a single 30 volt DC supply, that is as shown in here, and we will be short circuiting this 30 volt DC supply, and we will be noting down the branch currents, each branch currents using the ammeters in the three branches. Now this is the case 1. Now we will move to the case 2, where we will be short circuiting this supply voltage, this 30 volt DC supply, and we will be supplying this circuit from this side, and we will be supplying it with a 30 volt DC supply. And this time also we will be noting down the ammeter readings, that is which will be giving the current in each branch, that is in these three branches we will be noting the current using these three ammeters. So this was the case 2. Now in the case of, we will move on to the case 3, where in this case we are having that is in this case we will be supplying the circuit with two voltage sources, that is we will supply at both terminals. Here also we will provide 30 volt DC supply, and here also we will be supplying the 30 volt DC supply, and we will note down the ammeter readings in these three branches. So we can find here that the current in this ammeter will be in these three ammeters will be the algebraic sum of the currents which we obtained in the case 1 and case 2. So we will move to the case 1, that is how we are going to connect the case 1, where we are supplying this circuit with a single 30 volt DC supply. So we will be showing the connections for that. Okay. So here for this circuit we will be using this regulated DC power supply, which is called as RPS. This will be supplying this circuit with a 30 volt DC supply, so that we can ensure that it is giving 30 volt. Then we are this is actually connected using this 3 pin, and this is given to the socket, and we will switch on that, and from here we will be giving the supply. And in the supply, first we are having an ammeter, and I have told you that is the positive will be connected to the positive probe of this ammeter, and the negative will be connected to the negative part, and this negative is given to the rheostat, and we are using this rheostat in fixed mode only. You can see that, but we have connected it in the so here you can see that we have given it onto the variable portion, but here we have the provision of varying, but we are giving the entire resistance over here, even though it is connected in the variable part. Then from here we are having this is the second branch ammeter. You can see that this is a 0 to 100 milliampere ammeter. Here also the positive part will be given to the positive probe of this ammeter, and from the negative we have this 500 ohm 1.2 ampere rheostat, and then we have the ammeter, that is from this rheostat we are giving on to the third branch ammeter. This is a 500 milliampere ammeter, and all these ammeters which we use are DC ammeters, that is we are using moving coil instruments. So here you can see a straight line over here, which indicates this is a DC meter. and this is another rheostat. So this all these are connected in fixed mode only, but we are connected that as in the variable terminal, but it is in fixed mode only. That is, even though we have connected it as variable, whole 100 ohm will be there. Okay, if we are putting it here, we are giving a resistance of almost half what was there, that is almost 50 ohm. Now if we are putting it over here, we can see that the whole 100 ohm is available even if it is connected in the variable mode. Okay, so that can be used to change the current in each branch if we want. So switch on the supply. Switch on the supply and you can on this. Okay, so as this voltage is already 30 volt, there is no need to adjustment. So if it is not 30 volt, you can adjust it over here and make it 30. Now we can note down, now we have to note down the ammeter reading. So we can see that the first ammeter A1 is showing a reading of 150 milliampere, and the ammeter in between is showing a reading of 26 milliampere, and the ammeter in the third branch is showing a reading of 120 milliampere. Now we will go to the case 2 of the circuit. Here we will be giving 30 volt DC supply in this side, and we will be shorting this side and then finding the ammeter readings in each branch. Okay, so we will move to the connection of this. Okay, now we will switch on the supply. You have to adjust this coarse and fine adjustment and make it to 30 volt. So it is close to 30 now. Now we will take the readings in the ammeter. So while making the connections, you should be careful, because here while we are giving 30 volt over here, the ammeter terminals will be positive and negative in this sides, which was the reverse, which is the reverse of that what is made in the case 1. Here also the connection has to be changed. That is, here this terminal will be positive and this will be negative as the supply is from this side. Okay, so be careful while we are connecting in the case 2 part of this experiment. Okay. Now we can note down this ammeter readings. So this is the ammeter which is close to the supply, and you can see that it is reading a value of 150 milliampere. Now we will move to the ammeter which is in the middle. Okay, that is in the middle branch, and that is giving a value of 25 milliampere, as you can see. Then here in this ammeter, and in this ammeter you can see the reading as 125 milliampere. Okay, so now we will be connecting for the case 3, that is the part where we will be supplying both these terminals with the 30 volt DC supply. So I will connect accordingly. So you can see that we are having two regulated DC power supply over here, and we are giving a 30 volt DC supply on both sides. And like previous case, we are having 3 ammeters, and we have to look at the readings of these 3 ammeter. And while connecting the ammeter, you should check that the positive part of the supply is connected to the positive part of the ammeter. And in both these cases, we are connecting the positive part of the supply to the positive part of the ammeter. Okay. Now this is the first ammeter. as you can see, this is the, in this figure, this is the that ammeter. So while in the case 1, this ammeter was showing a reading of 150 milliampere and in one direction, and in the case 2, this ammeter was reading a current of 120 milliampere, but it was in the opposite direction. That is why while doing case 2, I have told you we have to interchange the connections in this ammeter as the current was in the opposite direction. Now you can see that is the case 3 where this both supplies are there. You can see that the current in this is 25. Actually we got case 1 150 and case 2 120 in opposite direction. So 150 minus 120, we will get 30 milliampere according to superposition. Here we are getting 25 milliampere. So it is almost confirming to the that is we are proving that is we can verify superposition theorem that way. Now we will move on to the second ammeter, that is the ammeter which is in this branch. Okay, so this is that ammeter, and as I have done in the case 1 and case 2, we can see that the current in case 1 in this ammeter was 26 milliampere, and while doing the case 2, the current in this ammeter was 25 milliampere, and the current was in the same direction. That is, there was no need to interchange the connections in this ammeter. It was the same throughout the experiment. So we can find that the direction of the current was the same, and also so we can find that now that the current in this ammeter is the sum of the case 1 and case 2 value, that is 26 plus 25, which is 51 milliampere, and this ammeter is reading 51 milliampere as you can see. Now we will move to the third ammeter. So here we can see that in the first, that is while it was in the case 1, we got a reading of 120 milliampere in this, and in the case of the second case, that is in case 2, it was 150 milliampere, and here the connections were interchanged, that is the current direction during the case 1 and case 2 were different, and so we can see that the current is 150 minus 120 milliampere, which is 30 milliampere according to the superposition theorem, and we are getting a reading of 25 milliampere here. So it is almost close. So thus we are able to verify superposition theorem using this experiment.